Welcome to the Design Thinking Project course. My name is Ben. In this course, a few instructors, including me, will guide you through an engineering design process to be able to learn, design, and construct a remote control system that is able to maneuver and achieve a few tasks. So throughout the course, you need to learn and understand the fundamental engineering principle in computer science, mechanical engineering, and electronic engineering. You don't just learn this principle, you are also required to combine the knowledge together through the engineering design process. The intended learning outcomes of this course are, at the end of the course, you will be able to understand basic engineering device and systems in mechanical engineering, electronic engineering, and computer science. You also need to be able to describe how engineers solve problems creatively and how they envision the future in a specific area, how to make things better and better. You also need to design and construct using a given set of material a remote control system that is able to maneuver and achieve a few tasks. And more importantly, you need to be able to present and reflect on the engineering design process. So the first question is, what is the engineering design process? Einstein said that scientists investigate that which already is, while engineers create that which has never been. One of the major activity of engineers is to create things, to create solution to a problem. So how to create? We create things to solve a problem through engineering design process. And the term design here is the art of problem solving. We don't solve a problem through trial and error. Engineering design process is the formulation of a plan to help an engineer to build a product with a specific performance goal. There is a specific set of process that we have to go through in order to find out a better solution to a problem. So what is that process? Here is a simplified diagram on what engineers will do when we try to figure out a solution to a problem. First of all, and probably the most important thing in the process, is to define the problem. Lots of people trying to find out a solution to a problem with given set of information. But in the real world problem, most of the time, we have to define the problem ourselves. Most of the time, we don't have a clear definition of the problem. We don't have a clear set of constraints to the problem. And these are the things that we have to define and set up at the very beginning of this design process. So after you design and define the problem, you need to explore information. Unlike analysis, where you just take out information from your own knowledge domain, in engineering design process, you have to explore extra information. You need to be able to look for new information that you need to design the solution of a problem. So after you explore all the possibilities, you come back and think about the solution. You always start with crazy ideas and you narrow it down from the divergent thinking point of view to a convergent thinking point of view. From crazy idea to feasible solution. The next step will be you start to create. The difference between creative and innovative is that innovative person will be able to exercise the idea and will be able to create things in the physical world. After the creation process, you have a prototype. Next thing you have to do is to try that out. If it doesn't work, you try it again. But even if it works, you have to try again as well. Because a solution in engineering problem doesn't mean it's the best solution. You have to keep moving, keep improving your solution in order to come up with a better one. So the thinking, creating, trying, and improving process form an iterative process. And it's something that you have to try it out not one time, not two times, but hundreds of times. Bear in mind that there is always a better solution somewhere. So before we talk about what are the things that you have to learn in this course, and before we talk about how to create the system at the end of the course, let me give you some information about how to come up with a good engineering solution. First of all, you have to make meaning of what you're doing. You will get frustrated if you don't have a well-defined meaning of what you're doing. What I mean is that, let me try to give you a few examples. Google. Before we have Google, if you want to look at information, you have to go to the library. And it is very difficult to consolidate knowledge and look for correct information that you want to do. But with Google, it aims to change the way people get and process information. And they succeed. Another example is Facebook. Before Facebook, we try to use conventional way to communicate with each other. We use face-to-face communication. Sometimes we use mobile phone, but it is still a lot of limitation in the process. We cannot do it anytime and anywhere we want. Facebook aims to change the way we connect with people, and this is the meaning of what they are doing. And that's the reason why they succeed. Next, you need to be innovative. Let me give you a typical example. The Burj Khalifa is the tallest building in the world right now. The total height of the building is 828 meters, about 300 meters taller than the previous tallest. So there is no guarantee that we can complete the project with the technology that we have at that moment. Indeed, at the level of about 600 meters, we are almost reaching the physical limit of construction. The difficulties by that time can be visualized this way. We are at the top of the Taipei 101. The workable area is about the size of a tennis court. What we need to do is we need to construct an Eiffel Tower on top of it. So physically, we cannot achieve the task. And in one stage, we cannot go upward any further. So how to do that? So the solution is just don't go upward. Here is a figure during the construction process. So you can see that the engineers leave a big hole inside the building intentionally. And the idea is that we don't go upward. We try to construct the last bit of the building inside the part that we already construct. So engineers actually create and compile the last bit of the building inside the existing structure and leave off the whole bit to form the top part of it. So this is the meaning of having an innovative solution. Don't restrict yourself by common sense. If you cannot go upward, why don't you go downward? So in order to achieve an innovative solution, you have to be able to jump from one level to a different level. When we try to look for a solution, we will always consider it in a two-dimensional manner. No one wants to fail. Although we are trying to say that engineers have to learn from failure, but no one wants to fail at the end. In order to guarantee the degree of implementation success. We try to limit our creativity. So the end result is we end up with a process. Let me give you another example. Motorola created the first mobile phone in 1973. And after that, there is a long period of mobile phone development. Every time we come up with a new phone, they are a little bit better. But if you look at the formation of the mobile phone, the concept is still the same. We have an antenna, we have a keypad, we have a screen, and the function of the mobile phone still remain more or less the same. And this is something we call progressive improvement, and it is indeed just a process. It's not a design that will improve the quality of life. So the opposite of a process is that we come up with a very crazy idea, very creative idea. But although the idea is far from the existing solution, the degree of implementation success rate is very low. So it is always in your mind. And this is not something we want either. An innovative solution is one that is having a good chance of success. At the same time, it has some kind of deviation from the status quo. The end story of the mobile phone is that we have someone called Steve Jobs who stand up and argue why a mobile phone have to be like this and why not like this. And this is how we change the world. This is how we come up with a good solution. Next thing is teamwork is very important in the process. Although in this course you are not going to practice your teamwork skill, but please bear in mind that in the real world problem nowadays, especially the grand challenges, the solution that you can solve by yourself, somebody have the solution already. And in order to solve the real world problem that we are facing right now, we are always looking for a multidisciplinary solution. And we always want to have people work together to come up with a good solution. So in the world right now, teamwork is something very important. And teamwork is not division of labor. And teamwork rely on a lot of communication, a lot of arguing, and a lot of discussion. And this is something that you have to spend time and practice before you can master it. Last thing, and it's probably the most important thing, is that you need to be able to enjoy the process. It is very important in engineering, especially in the practice of the engineering design process. Try to imagine that you're working on something that have no guarantee of success, and you will never know when you will achieve a good solution, or you will never know whether you have a solution or not. So the process, I would say, is dark. And it's probably very dark. But trust me, there's always light at the end of the tunnel. When you come up with a solution at the end, then you will start to think that the time that you spend is all worth it. So try to enjoy the process, and I hope for this course you will be able to understand what is the real meaning of the engineering design process.